There is a place on the planet where the whole world holds its breath. A narrow corridor, just over 30 kilometers wide in some stretches, through which about 20% of all the oil consumed on the planet passes. The Strait of Hormuz. Today it has returned to the center of global tensions, with conflicts between Iran and the United States, attacks on ships, and constant threats of blockade. And this small stretch of sea has become one of the biggest risks to the world economy. Because if Hormuz closes, the regional impact becomes global. Fuel prices rise, supply chains stall, and entire countries go on high alert. It's exactly in this scenario that a strategic infrastructure built decades ago returns to center stage. A system that crosses the Saudi Arabian desert with a clear goal: to reduce dependence on this bottleneck. We're talking about the East-West Pipeline, or simply Petroline, an operation that moves billions, and with continuous investment can reach figures equivalent to about $7 million per day. Stay with us for the next few minutes and understand how this feat of engineering became a direct tool of geopolitics. To understand this structure, we first need to look at the map carefully. On one side, the Persian Gulf, the Red Sea. Between them, a brutal stretch of desert that crosses Saudi Arabia from east to west, connecting two of the most strategic points in global energy trade. It is exactly along this axis that the East-West Pipeline is located, a system about 1,200 kilometers long that connects the oil fields of eastern Saudi Arabia to the port of Yanbu on the Red Sea. For years, it operated as a strategic alternative. Today, with rising tensions in the region, it has come to be used much more intensively, taking on a central role in the country's energy logistics. More than just a simple alternative, Petroline is a land route capable of maintaining the flow of exports even in the face of maritime instability. It is not a new project being built from scratch, but an existing infrastructure that has been adjusted, optimized, and is now being pushed to the limit of its operational capacity. But after all, why has this project become so critical at this moment? The answer to the question from the previous section goes back decades. It was a time when the world was still learning to deal with the risks of the Middle East. During the Iran-Iraq War in the 1980s, the so-called Tanker War episode showed how maritime routes could be interrupted with relative ease, directly affecting global supply. It was in this context that Saudi Arabia decided to take action and create a land-based alternative outside the direct reach of naval blockades. That's how the East-West Pipeline was born, conceived as a strategic contingency solution, a plan B for times of crisis. For many years, the pipeline fulfilled this role discreetly, serving in a complementary role. But the global energy landscape has changed. Consumption increased, supply chains became more sensitive, and geopolitical tensions never ceased to exist. Recent episodes, such as attacks on Saudi energy infrastructure and recurring threats involving the Strait of Hormuz, have put this type of alternative route back at the center of strategic decisions. Today, relying exclusively on the Strait of Hormuz represents a significant risk. And that's why Petroline has ceased to be just an alternative and has become a top-tier strategic asset, with intensified use and operational adaptations to handle scenarios of higher demand. The logic is straightforward. If maritime flow becomes uncertain, the land route needs to absorb part of that pressure. But operating at this level requires much more than simply having a functional pipeline. Running and maintaining an energy corridor of over 1,000 kilometers in the heart of the Saudi desert is not just a matter of scale, but of continuous adaptation to extreme conditions. The environment imposes significant challenges: high temperatures, thermal variations throughout the day, and soils with variable geotechnical behavior along the route. In regions with more stable soil, stabilization and settlement control measures were adopted, while rocky areas required specific excavation and laying techniques. The pipelines are made of high-strength steel, use anti-corrosive coatings and production systems along their length, as well as constant integrity monitoring. The assembly of the system involves field welding, integrity testing, and commissioning steps before entering into operation. These processes follow established standards in the oil and gas industry with a focus on safety. One of the most important elements of the project is the pumping stations distributed along the route. They are responsible for maintaining the continuous flow of oil over hundreds of kilometers, compensating for pressure losses and ensuring stability in transportation. These stations operate with a high level of automation and are integrated with monitoring systems that track parameters such as pressure, flow, and operational conditions in real time, allowing dynamic adjustments according to demand. Another relevant aspect is the safety of the infrastructure. Because it is a strategic asset, there is continuous monitoring along the route, with different layers of surveillance and operational control. From a technical and structural point of view, the project takes into account the environmental conditions of the desert, with engineering solutions aimed at ensuring the stability of the system over time, even under significant climate variations. A key factor in keeping this infrastructure running is maintenance. Unlike conventional linear infrastructure projects, pipelines of this size run almost continuously, which requires specific inspection and intervention strategies. Sections of the pipeline are periodically evaluated with internal inspection tools, known as instrumented pigs, which are capable of identifying corrosion, deformations, and thickness variations along the pipeline. Inspections help build detailed integrity records, making it possible to carry out preventive interventions before any failure manifests itself in a critical way. Another important point is the operational logistics of the stations. Each pumping unit functions as a node within a larger network, and its performance directly influences the behavior of the system as a whole. Small variations in pressure or flow at one point can generate cumulative impacts over hundreds of kilometers, requiring fine control and quick response. In this sense, the integration between sensors, control centers, and human operators is fundamental. Now, looking at the current status, Petroline is not being built from scratch, but rather used more intensively and adapted to operate close to its maximum capacity at certain times. Recent reports indicate that the pipeline has been used to redirect significant volumes of oil in scenarios of increased tension in the Gulf, reinforcing its role as a strategic alternative to the Strait of Hormuz. The operational capacity is up to 7 million barrels per day, with this volume often cited as the project's approximate technical limit. More than massive physical expansion, what we see is an increase in operational relevance, with adjustments, maintenance, and occasional improvements aimed at ensuring the reliability and availability of the operation. In addition, there is an important change in the way this infrastructure is used within the Saudi energy strategy. Instead of operating only as a secondary route, the Petroline is now incorporated more actively into logistical planning, serving as a real alternative in high-risk scenarios. This repositioning requires more than just a robust structure. It demands operational responsiveness, integration with port terminals, and coordination with global export flows. In this context, the Petroline ceases to be just a support asset and becomes one of the main energy export routes for Saudi Arabia during critical moments. Now, to really understand what is being built here, it's worth taking a step back and translating this scale into something more tangible. Because numbers like 1,200 kilometers or $7 million per day are impressive, but still abstract for most people, when we put this into the real world, the scale changes completely. We're talking about a corridor that practically crosses an entire country, equivalent to the distance between São Paulo and Salvador. Infrastructure that, if it were in Brazil, would connect entire regions and reshape national logistics flows. And there's still a daily cost. This one is even more revealing. $7 million per day means almost 37 million Rs considering the exchange rate at the time this video was made. With that amount, it would be possible to build about 150 meters of subway in São Paulo every day, or buy 493 economy cars worth 75,000 Rs each every single day without interruption. In just 1 month, the investment exceeds the 1 billion Rs mark. When compared to other global megaprojects such as the Druzhba pipeline in Europe or energy systems in Russia and the United States, the East-West pipeline ranks among the largest on the planet, but with one essential difference. While many of these projects were designed for economic efficiency, this one was conceived for strategic necessity. In fact, here, every meter built is a direct response to global risk. The future of this operation points to something that goes beyond engineering or logistics. It reinforces the role of Saudi Arabia as one of the main agents of stability in the global energy supply. By operating the petroline at high utilization levels, the country is able to reduce part of its exposure to risks associated with the Strait of Hormuz, even though it does not completely eliminate this dependence. This allows for greater flexibility in oil exports, especially via the Red Sea, opening alternative routes and increasing the ability to respond in scenarios of regional instability. Domestically, the impact is also significant. The operation and maintenance of infrastructure of this scale require a high level of technical expertise, which helps develop a more skilled workforce, the application of industrial technologies, and the operational efficiency of the energy sector. On the global stage, the effects are indirect but important. The existence of alternative routes helps to mitigate the risks of supply interruption, which can help reduce extreme volatility spikes, even though it is not by itself capable of stabilizing the international oil market. In the end, this infrastructure sends a clear message. More than just a project, it is a strategic decision built over time. By turning the desert into an alternative to the Strait of Hormuz, engineering ceases to be just technical support and takes on a central role in global geopolitics, showing that, in times of uncertainty, the ability to anticipate risks can be just as important as reacting to them. Thanks for watching. What are your thoughts on this alternative to the Strait of Hormuz? Do you find it relevant? Or do you think it won't have much of an impact on the global energy export scenario? Leave your opinion in the comments. That's all for now. Take care and see you in the next video.